Hello students, all good. We are in the last part of the first chapter for chemistry, chemical reaction and chemical equation. And before we start, I want all of you to get a paper, rough book, pen, so that we could all go along, because science you learn by practicing. So let's start. Last class, if we have stopped somewhere in between oxidation, reduction, and today we are about to start the redox reaction. Redox reaction. So let's quickly recall what we have studied last class. Reduction for red, ox for oxidation. And also we have differentiated oxidation and reduction. Reduction is loss of oxygen or removal of oxygen, and oxidation is gaining of oxygen. So this equation I have given you in the last class. Cupric oxide, Cu stands for copper, O is oxygen here, so together it is cupric oxide. CuPric OXide. And this is hydrogen. So together it gives. So we get copper and H2O here. So here reduction takes place here, where there is a loss of oxygen. So this is what we have studied, but I have given you a common example equation so that we could use this same equation for the total redox reaction. Because if you look at this equation carefully, here reduction takes place, and here, if you look here, now oxygen has been added here in the product. If we see, then oxidation also takes place here. So if you see here, reduction has taken place here, and oxidation has taken place here. So together in this equation, what we get to see is reduction and oxidation is taking place simultaneously. So this is an example for redox reaction. And the definition for redox reaction is those reactions in which reduction and oxidation take place at the same time or simultaneously. So you can write this as example for redox reaction. So the same example you can write for reduction as well, but whenever you write for reduction, don't show this. You can just show like this. Or if you just want to show this equation for oxidation, then you can just write like this. Clear? Student, I'm sure you're getting this point. You have to locate oxidation and reduction, that's it. And for redox reaction, you have to show both the reduction and oxidation. Clear? So if you are clear with this point, the next topic would be oxidizing agent and reducing agent. Oxidizing agent and reducing agent. So oxidizing agents are those which oxidize other and itself gets reduced. And reducing agents are those which reduce other and itself gets oxidized. So if we see here, hydrogen gets oxidized and cupric oxide gets reduced to copper. So now we can say that this one here is an oxidizing agent. Because of this, hydrogen has oxidized. And now we can say that this one is a reducing agent. Hydrogen here is a reducing agent here because cupric oxide has reduced to copper. So please note down this definition and equation as well. And this equation, whenever you write this equation, you have to mention everything clearly, and you have to write where the reduction is taking place, where oxidation is taking place, and which one is an oxidizing agent and which one is a reducing agent. Reducing agent. So I have written here, this hydrogen is a reducing agent, and cupric oxide here is an oxidizing agent. So please note down, and if you are clear with this topic, we'll go to our next topic. That will be the last topic for this chapter. That is effect of oxidation in everyday life. So the name of the topic would be corrosion and rancidity. Students, our topic here, corrosion. What is corrosion? So I want to ask you, have you ever wondered why do we have to paint on the metal surface? Or why does the roof, I mean the metal roof, look shiny? Or if you go to your washroom, if you see the tap, you see that it is shiny. Why does it look shiny? Or why does, I'm repeating again, but why do we have to paint a metal? Or why do we have to apply a grease? Or why do we have to oil the machines? Why? The answer is to prevent them from getting corrode. Clear? The answer is to prevent them from getting corrode. And in case of metal, we can say that that is rusting of iron. In case of iron, we can say this, rusting of iron. Why rusting of iron take place? It's because the metal surface are exposed to air. Clear? The metal surface, they are exposed to air. So what happens is that they react with the action of air. They react with the action of air, water. Water can also be in the form of a moisture or water vapor. Air, water vapor, or any other substances such as acids, or we can take as salts, etc. Clear? So let me repeat it again. Metal surface on exposure to the action of air, water, acids, and salts, what happens? The corrosion takes place. And this process together, it is known as corrosion. And we have many steps, we have many prevention from the metals to get corrode, or we can prevent the iron from getting rust. Like the first one would be painting. Painting, that's the common one, that's why I'm giving it. The second one is oiling. Oiling can also prevent from any metal to get oxidized. Clear? Now, the third one, we can say it is galvanizing. Galvanizing. So, I'm not talking about the brick roof, okay? I'm not talking about the brick roof, but the steel or that metal roof looks shiny, right? Or we call locally we call it as tina, right? So it looks shiny. Why does it look shiny? Because it has been coated with zinc. So it comes under galvanization. So this, the third process also we can apply to prevent the metal from getting corrode. Clear? The fourth one, what we can do is we can do electroplating. This is also another form to prevent metal or from getting corrode. So remember these 4 points. We have many points, but 4 points is enough. It's okay. And why does this corrosion take place is because of oxidation. Metal surface get exposed to the air. Clear? Okay. So if you are done with corrosion, our next topic would be rancidity. 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 Students, this is our last topic, rancidity. And rancidity is very common. Let's take an example from your own kitchen. Have you ever observed foods, if you keep like for 2 days, you observe a unpleasant smell, or unpleasant smell or taste, or you will get a foul odor, okay? Okay, students, when you keep your food opened for 2 days, or maybe even like in the summertime, just for few hours also, the food might get, you might get to observe a very unpleasant smell, foul odor, or even the taste will not be as good. The taste will not be good. Why? Because rancidity takes place. It becomes rancid. Because the oil and fats, okay, fats. Oil and fats are present in the food. And when they are exposed to the air, oxidation takes place. In other words, they get oxidized. So that is the main reason why our food and oil are kept in a refrigerator, or they are packed in an airtight container. So that's the basic reason why we do that at home. So I'm sure you are clear with the concept for rancidity, which means spoilage of food because of oxidation. Clear? And to prevent that, that I will give you as a homework, you can try. The basic two examples I have given, that is refrigeration, or the second one, keep the food in an airtight container. The third one is homework, you can try it. So that comes to the end of this chapter. We have covered everything from this chapter, starting from chemical reaction, chemical changes, chemical equation, different types of chemical reactions, and oxidation, reduction, redox reaction, oxidizing agent, reducing agent, corrosion, and rancidity. So please go through the chapter again, note the important points, and from this chapter, definitions are important. To how to balance the chemical equation is very important, and to identify the chemical equation is very important, because in exam you might get an equation and you'll be asked to identify what kind of chemical equation is. So I'll give you 1 or 2 questions so that you can go through this and you can identify. Let's try this question here, 1 question here. Let's take silver nitrate here, and let's take potassium bromide, which gives okay. So this reaction, let me repeat it for our viewers who are listening just the voice clip. We have silver nitrate, AgNO3 is a silver nitrate. KBr is potassium bromide. So when they react together, we get silver bromide and potassium nitride. So here, silver bromide we get in a form of yellow PPT, PPT, I have given explanation in our last class. That is a precipitation. That is the insoluble one. So here, students, can you guess what type of chemical reaction is this? This is one of the types of chemical reaction that we have studied in our last class. So here, what's happening? I have given you an example of exchanging cars. Okay, so this is an example of double displacement reaction. Double displacement reaction. Clear? Okay, so this is just one basic type of example we did, but I request you all to try many questions given the textbook. Clear? So in the next class, we'll start with new chapter that is acid, base, and salt, chapter 2 for chemistry. And I'm telling you, this chapter is going to be very interesting. We'll have a lot of practical example, and we will be doing lots of activity as well in acid, base, and salts. So yes, next class we'll start with the chapter, but today I would just to get familiar with the chapter so that it won't be very new or it might not sound alien to you. Let me give you a brief introduction regarding the chapter. Clear? So acid, base, and salt. So what is acid? Acid is dangerous. Or if I say acid, what comes to your mind, students? If I say base, what comes to your mind? So have you ever tasted a lemon? I'm sure you have all tasted a lemon. What kind of feeling do you get? So first, we'll study the physical properties of acids. Clear? So lemon is sour in taste, right? So lemon is also an acid. So acids are sour in taste. Acids are sour in taste. Please keep this in mind. So I'm giving you an introduction for the acid, base, and salt to get more familiar with this chapter. The detail part of this chapter we'll do in the next class. And base. So acid, they are sour in taste. So how would the base taste? And what is base? Base are bitter in taste. Bitter in taste. Bitter in taste. Clear? Okay, have you ever tested a soap? No, and I'm sure don't test that at home because soap is an example of base and they are bitter in taste. But please don't taste it. You can taste lemon, that's an example of acid, but soap, please don't taste it. So, but soap is an example of base. Now, how do we get acid, or what is an acid? Acids are those which on dissolving with water. Okay, let me give you with a very simple word. On dissolving with water, give hydrogen ions, H+. Remember, this is very important, hydrogen ions. So these are acids, hydrogen ions. So acids are those which on dissolving with water gives H+ ions or hydrogen ions. Clear? Now, what about a base? What are base? Base are those which on dissolving with water gives hydroxide ion. This is very important, class. OH ions. You can simply write like this, okay? So class, look here, acid H+, base OH-. Keep this in mind. So now let me give you some example of acids. Let's say H2SO4. That is a sulfuric acid. Sulfuric acid. So from the name itself, we know that it's a sulfuric acid. So what we are getting to see here, we're getting to see here H. Now let's take example of HNO3. That's a nitric acid. Nitric acid. So even here we're getting to see H. Clear? So now let's take example for base. NaOH is a base. Why? Because we get to see OH here, and I have already said that OH means it's a base. So NaOH, it is sodium hydroxide. Sodium hydroxide. And class, do you remember I said calcium hydroxide? I have also given you a common name for calcium hydroxide, that was slag lime, CaOH2, calcium hydroxide. That is also an example of a base because they have OH. And now if we see here, if we look here, they have plus, minus. That's why we call them ions. So the next point you can write, they are good conductor of electricity. Since they have charge, since they have ions, they are good conductors of electricity. Good conductors of electricity. Good conductor of electricity. Even the base, they are good conductor of electricity. It's the same here, okay? Good conductor of electricity. So I've listed some points, basic physical property and a difference between acid and base. So please write all these points down. And now let's see what happens when acid and base together, they meet. When there's a reaction between acid and base, what happens? So when acid, and I'll just write here in front of word, acid and base. Acid and base. If they react together, we will see salt and water. Okay? Acid and base reacts together to give salt and water. And this process is also known as neutralization reaction, students. So now let's give any example for acid. Let's give HCl. HCl is a hydrochloric acid. HCl is a hydrochloric acid. Let me write here, HYDRO, hydrochloric acid. This is also one of the very strongest acid. So we have acid. I've just given an example here. I've given an example, strong acid, HCl. Base, let's give a base, let's give another strong base. Let's pick from here, NaOH, it's a base. So let's give NaOH. So now let's see what happens when they meet together. So we have here acid and we have here base. Now if they meet together, what we will get? We'll get salt and water. Water, we all know it's H2O. Correct, students? H2O. So now what is left? 2H is gone, 1O is gone. That means we are left with Na and Cl. And NaCl is sodium chloride, and that is the common salt that you and I consume at home. So this is a common salt, okay? NaCl is known as a common salt, and the chemical name will be sodium chloride, and this NaCl is the common salt that we consume at home. Clear? So I'm sure you have got a little bit idea of what acid and base are. And if you are clear with the physical property and the reaction between acid and base, we will Now we will see how do we know which one is acid, or how do we know that this is a base? How will we differentiate, or how will we measure them? Clear? So we will explain this pH scale. We will explain this pH scale in detail in next class. But what I want to say today is pH less than 7 is known as acid. And pH greater than 7 is base. Clear? pH scale we have from 1 till 14. So 1 to 7, that 1 to 7 is an acid, 7 is a neutral number, remember. 7 is a neutral number, and from 7 till 14 it's a base. So pH less than 7 is an acid, and pH greater than 7 is base. And the 7 is the neutral number. That's the neutral. Clear? So let's say, what is the pH of water? So the pH of water is 7, and that's neutral. So water is neither acid nor base, but it can be acid. Acid rain, I'm sure you have heard of. That's when the pH goes lower than 7, where we get like acid rain. Clear? Okay, class. So we have gone through the brief introduction for acid, base, and salts. So whatever today we have discussed are all to give you a general idea of what we are going to study. So in next class, we'll study more in details, and like I've said, we'll be dealing with more practical examples, and if possible, we'll also do some activity where I'll give you some activity where you can do at home. Clear? Students, thank you so much. Stay safe. See you in next class.